Welcome back to Mr. Vaughn's classroom. Before we get started with this lesson, I'd ask you to please hit the subscribe button and give this video a thumbs up. Today we are looking at Unit 4 about functions, Lesson 8, interpreting and creating graphs. The learning goal today is to sketch graphs to represent situations. We have 3 learning targets today. As we go through the practice problems, you want to keep these 3 things in the front of your mind, and if by the end of this lesson you are not comfortable making any of these statements, please ask for clarification by dropping a comment below. Learning target number 1, I can explain the average rate of change of a function in terms of a situation. Anytime you see average rate of change, remember we're talking about the slope. Learning target number 2, I can make sense of important features of a graph and explain what they mean in a situation. And learning target number 3, when given a description or a visual representation of a situation, I can sketch a graph that shows important features of the situation. So we really want to make sure that we understand how to draw the graphs. Our first term is average rate of change. The average rate of change of a function f between inputs a and b is the change in the outputs divided by the change in the inputs. It is the slope of the line joining the point A, f of A, and B, f of B on the graph. Remember, we are talking about the slope, and the slope is the change in y over the change in x. So when you're looking at this f of b minus f of a, what that is really showing you is you're taking the second y and you're subtracting the first y. And then where it has b minus a, you're really taking the second x and you're subtracting the first x. So even though we're changing how we're representing these things, this is still just your basic understanding of slope. It is still just how much did I change in the y direction divided by how much did I change in the x direction. Our next term is decreasing function. A function is decreasing if its outputs get smaller as the inputs get larger, resulting in a downward sloping graph as you move from left to right. At the bottom, you can see an example where they give us a function, and you notice that the right side of the parabola is bolded, and that's because for that domain, you can see the y value is decreasing as we go left to right. That means for that part of the graph, it is a decreasing function. Our next term is horizontal intercept. The horizontal intercept of a graph is the point where the graph crosses the horizontal axis. The way that I remember this is that a capital H has that crossbar, that sideways line in the middle. So horizontal is your sideways left to right, as opposed to your vertical, a V is made up of 2 lines going up and down, so your vertical would be up and down. Here, your horizontal intercept is where your graph crosses that horizontal or side-to-side axis. In other words, your horizontal intercept is your x-intercept. And remember that if you are on the x-axis, then your y is always going to be 0. So your horizontal intercept is going to be a point pair where you have some value for x and you will always have 0 for the y. Next, we have increasing function. Here, a function is increasing if its outputs get larger as the inputs get larger, resulting in an upward sloping graph as you move from left to right. So in other words, an increasing function is going to have a positive slope. You can see in the example at the bottom, the left side of the graph is bolded because as you're going from left to right, your y value is increasing and that line is going up from left to right. Our next term is maximum. A maximum can either be the maximum of the function, which means the highest y value on the graph, or you could even say a local maximum where you're limiting yourself to a certain domain and you're looking for the highest point within that domain of x values. Our next term is minimum. This is just the opposite. Now we are looking for the lowest y value on the graph, or we could be looking for a local minimum where we're limiting ourselves to a specific domain of x values and we're looking for the lowest y value within that domain. Our next term is vertical intercept. The vertical intercept is also known as your y-intercept. This is any point where your graph is crossing the y-axis or the vertical axis. Remember, if you are on the y-axis, then you are at an x value of 0. So your vertical intercept will always have an x value of 0, and then you will have some y value. Now we can look at the practice problems for Unit 4, Lesson 8, Interpreting and Creating Graphs. The graphs show the distance d traveled by two cars, A and B, over time, t. Distance is measured in miles, and time is measured in hours. Which car traveled slower? Explain how you know. So, I want to make sure we understand distance is being measured using d, and it's measured in miles. And that is going to be our y-axis, or our vertical axis. Next, make sure we understand that time is represented by t, and time is measured in hours. And that is going to be represented by the x-axis, or the horizontal axis. Now, the blue line is representing car A, and the black line is representing car B. And they're wanting to know which car traveled slower. So in order to know which car traveled slower, what we're looking for is that rate of change or the slope. So what I'm going to do is I'm going to pick a point on each line where they have gone the same amount of time, and I'm going to compare their slopes. So what I will do is I will pick right here at 150, and I will pick the point right here at 4. This would end up being 200. So if they both start at 0, 0, then car A slope is going to be the change in y. So that's 150 minus 0 over the change in x. That's 4 seconds, or 4 hours, minus 0 hours. So that's 150 miles traveled in 4 hours. That's 37.5 miles per hour. Now we can look at car B. Here, my second y is 200 miles minus my first y, 0 miles, divided by my second x, 4 hours, minus my first x, 0 hours. That becomes 200 miles divided by 4 hours, which is 50 miles per hour. So, if I want to answer this question, car A traveled slower because 37.5 miles per hour is less than 50 miles per hour, and the slope for car A is flatter than the slope for car B. So what I'm saying here is that you can either calculate the slopes and compare them and see that the slope for car A is less than the slope for car B, or you can look at the graph itself and you can see that car B has the line that is steeper or more up and down than the line for car A. The line for car A is flatter than B. The flatter that line is, the slower the rate of change, or the lower the slope. The higher that line is, or the steeper that line is, then the faster the rate of change, or the higher the slope. So either method will lead you to the correct answer. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with more clarification. Our next practice problem says here are descriptions of 4 situations in which the volume of water in a tank is a function of time. Match each description to a corresponding graph. So, what we need to understand here is volume of water in a tank is a function of time. That means water is the y value and time is the x value in all of these. So when we start down here at the bottom, it means the tank is empty. When we start up here at the top, it means the tank is full. So we have 4 graphs, we have 4 descriptions, and we need to match them. So, first description says, an empty 20-gallon tank is filled at a constant rate for 3 minutes until it is half full. Then it is emptied at a constant rate for 3 minutes. So I need to start empty. So that means it's either 2, 3, or 4. I need to fill at a constant rate until it is half full. Then I need to empty it. Well, that is what I see when I look at this picture on graph 3. I see it start empty, fill halfway, and then empty back out. So that means A matches graph 3. Description B. A full 10-gallon water tank is drained for 30 seconds until it is half full. Afterwards, it gets refilled. So we know that it starts out full, it's drained for 30 seconds until it is half full, and then it's refilled. And the only graph that starts full is graph 1. We see it start full, drain halfway, and then get refilled. So that means description B matches graph 1. Description C. A 2,000-gallon water tank starts out empty. It is being filled for 5 hours, slowly at first and faster later. So as we look, graph 2 starts empty, starts being filled slowly because this line is flatter, then it fills more quickly so the line gets steeper. That means description C matches graph 2. And finally, description D, an empty 100-gallon water tank is filled in 50 minutes, then a dog jumps in and splashes around for 10 minutes. So if a dog jumps in and splashes around, it's going to lose a little bit of water. Here It says letting 7 gallons of water out. The tank is refilled afterwards. So if you look at graph 4, you can see that this empty tank is being filled. Then the dog splashes around and lets out a little bit of the water, and then it finishes being filled. So description D matches graph 4. If you have any questions about how to take descriptions and match them to their graphs, please ask for clarification. You can drop a comment below, and I'll get back to you with any help that you might need. Our next practice problem, Claire describes her morning at school yesterday. I entered the school on the first floor, then walked up to the third floor and stayed for my class for an hour. Afterwards, I had an hour-long class in the basement, and after that I went back to the ground level and sat outside to eat my lunch. Sketch a possible graph of her height from the ground floor as a function of time. So notice that the x-axis is going to represent time, and the height above ground level is going to be the y-axis. This means ground level is going to be on the x-axis. So, first, I entered the school on the first floor, then walked up to the third floor. So we start at the origin and we show her walk up to the third floor. Next, it says she stayed for my class for an hour. That means the height isn't changing. She's staying on the third floor. Next, afterwards, I had an hour-long class in the basement. Well, first, we need to get her down to the basement. And the basement is going to be below ground level. Then, we're going to show that she stays there for an hour. And finally, after that, I went back to the ground level and sat outside to eat my lunch. So we need to show her go back up to the ground level and then stay there to eat lunch. So what we've done is we've broken down each sentence and showed each step that she made. The pink line represents entering on the ground floor and then walking up to the third floor. The green line shows her staying in class for an hour, so her height doesn't change. The yellow line shows her go from her class on the third floor down to a class in the basement below ground level and stay there for an hour. And then the blue line shows her go back up to the ground level and then sit outside to eat her lunch. So this is a possible graph that would represent this situation. If you have any questions about how to take a situation and turn it into a graph, please leave a comment below and I'll get back to you with any clarification that you might need. Our last practice problem, Tyler filled up his bathtub, took a bath, and then drained the tub. The function gives the depth of the water in inches t minutes after Tyler began to fill the tub. These statements describe how the water level in the tub was changing over time. Use the statements to sketch an approximate graph of the function. So first, we have b of 0 equals 0. This means at 0 minutes, the depth was 0 inches. I'm going to represent this with a red point right here at the origin. Now I'm going to go to the third description. b of 9 equals 11. This means at 9 minutes, the depth was 11 inches. I'm going to represent this with a blue point. I'm going to go over to 9 minutes, up to 11 inches, and I'm going to put that blue point right there. Now, I'm going to go back to the second description, and I have b of 1 is less than b of 7. This means the depth at 1 minute was less than the depth at 7 minutes. To represent this, I'm going to use the blue highlighter line. So I'm just going to connect these 2 points to each other. And on this blue highlighter line, you can see that the depth at 1 minute is less than the depth at 7 minutes. The fourth description they gave us is that b of 10 equals b of 23. That means the depth at 10 minutes equals the depth at 23 minutes. So what I'm going to do is I'm going to say that the tub was filling up between 0 minutes and 9 minutes. And now I'm going to use this pink highlighter line to say that up until 23 minutes, the water stayed the same. And so now we can see that at 10 minutes and at 23 minutes, the water was the same depth because the tub had been filled and Tyler was simply taking his bath at that time. And then our final description is that b of 20 is greater than b of 40. That means the depth at 20 minutes is greater than the depth at 40 minutes. So what I'm going to do for that is use a green highlighter line, and I'm simply going to say, okay, well, at 23 minutes, we started draining the tub. It emptied at 40 minutes. And now we can see that at 20 minutes, the tub was filled. Tyler was taking his bath. Then it was emptied after that. And at 40 minutes, the tub is empty. So the depth at 20 minutes is greater than the depth at 40 minutes, because at 20 minutes, the tub was full. And at 40 minutes, the tub was empty. If you have any questions about any of the practice problems that we went over in this lesson, please be sure to leave a comment below. I will get back to you with any clarification that you need. If you found this lesson helpful, please hit the subscribe button and give this video a thumbs up, and I look forward to seeing you in the next lesson.